Here we have a rational expression that has fractions embedded within another fraction. Our plan is to multiply both the numerator and denominator by the least common multiple of these lesser denominators to get rid of the fractions that are embedded within the greater fraction. So looking at these three denominators, the least common multiple would be 25 times x minus 1. So I'm going to multiply by a special version of the number 1 that will cancel out all three of these denominators. So I'm going to multiply the numerator of this greater fraction by 25 times x minus 6. Now to keep the value of this entire expression equivalent to what we started with, whatever we multiply the numerator by, we need to multiply the denominator by the same thing. So we'll multiply down here by 25 times x minus 6. Now all we've really done is multiply by a special version of the number 1, because the value of this whole expression here equals 1. The next step is to distribute. So I'm multiplying 25x times x minus 6 times 5 over x. And then 25x times x minus 6 times x over 25. In the denominator, we are ready to start canceling because we have everything broken up into factors. So we have x minus 6 divided by x minus 6 is 1. So we're left with x squared times 25 times x. Turning our attention back to our numerator, in the first term we have x divided by x is 1, so those cancel out. And we have 25 divided by 25 equals 1, so those cancel out. And I'll go ahead and multiply 5 times 25 and x times x. In the denominator, we can multiply x squared times x and put the 25 out front. You can distribute the 125 and distribute the negative x squared. And now we need to combine like terms in the numerator. We'll start with the highest power and move down to our constants. Turned out we didn't have any like terms, and we noticed that none of the factors of the denominator could possibly be factors of every term in the numerator, so we don't need to simplify this any further. On a technical note here, we notice that in the original expression we have some excluded values. X cannot equal 0. And x cannot equal 6, because those would make denominators 0. We don't need to worry about the x equals 0 because that's evident from our answer here, but we really should make a note that this expression is equivalent to the original one only for x's not equal to 6.